Okay, so now we have a separable differential equation that has an initial condition to it. So it's a separable differential equation with initial condition. So we're gonna have to solve this differential equation, and then we are going to look for that C, that arbitrary constant. Okay. Okay, so the first thing to do is to separate them. So we need to move the tangent to the other side, and we need to move the dx to the opposite side. So this would mean the dy divided by tangent of y is going to equal negative 2x dx. Okay. But integrating 1 divided by tangent of y is not necessarily something that you want to do. So we're just going to use a little bit of trick and say, 1 divided by tangent is really cotangent. Okay. Now, integrating cotangent of y with respect to y, people always have trouble with this one, but if you just know that the integral of tangent is the natural log of secant, well, then the integral of cotangent is the negative natural log of cosecant. Okay, but I don't like all those minus signs on there. So what I'm going to do is I'm going to see. I don't know. So the log of cosecant of y is going to equal x squared. Remember, just gonna say plus c2. So I don't want to write negative c1. Okay, so all I did was multiply both sides by -1. Okay, then we could raise both sides above e. Okay, and that would give us that cosecant of y is going to equal e the x squared times c. Because remember, e to the c2 is just going to give us the c. Okay. And then we're going to use the condition that y of 0 equals pi over 2. Okay. So that means that cosecant of pi over 2 equals e to the 0 times c. Okay. Honestly, in my class, if you left that as cosecant of pi over 2, it's totally fine. But what is cosecant of pi over 2? Well, think about it. Cosecant is really 1 divided by sine. Okay. And sine of pi over 2 is 1. So if you have 1 divided by sine of pi over 2, that's 1 divided by 1. It's really 1. And so we're going to get from this that 1 equals c. Okay. And so we would say, you know what? I would write the solution to this problem as just cosecant of y equals e to the x squared. Okay. And you may ask yourself, well, you got this cosecant of y equals e to the x squared. So why don't you just write it as y equals cosecant inverse of e to the x squared? Cosecant inverse is just not really something that you want to mess with. So this one actually, even though you can solve it to an explicit extent, its implicit form in this way right here is actually more useful. than getting into the explicit form. So in this one, I would actually leave it as this, as implicit, rather than converting it into explicit.